Hi, everybody. Welcome to another session of DevUp, where Adam Olshansky and I riff about concepts you need to learn for starting a career in development without a background in development, or maybe developers just looking to get a little better understanding of some of the core concepts that you need to learn before getting into Salesforce development. I'm Paul McCollum. I'm a cloud architect at Accenture, and you can catch me on Twitter at UXaholic. Adam?
And my name is Adam Olshansky. I'm a developer and architect for Salesforce for Google Play. And you can also find me on Twitter at Adam17AMO. I think I had a typo in my name.
And you're a how many time MVP, Adam?
I think so. I was fortunate to just get renewed again. So I think it's 5 or 6 now. But also some certifications and really enjoy talking coding on the Salesforce platform.
Great. Yeah, Adam's one of the people that I followed into the Salesforce ecosystem, so I'm excited to be able to partner up with him and help bring in more developers into the world. So without much further ado, we'll get started. So in our last session, my keys aren't hitting, we talked about objects and relationships, rows and columns. So if you've used a spreadsheet, you kind of have an idea of what a database program is, or at least how data is stored in structures. Columns are the fields and rows are the records. So it's a core building block of any application is building a relationship between records. And so you'll need to have an understanding of how that works. IDs in Salesforce are very important as far as in database parlance. The ID is the primary key of a table record. And you'll need to understand that those and how important those are inside of working with Salesforce data. So that was the subject of our first video. If you missed that, go catch that on objects and relationships, yep. And here we're going to be talking about SQL and SOQL. Now, SQL is a 40-year-old language designed to make pulling data and pulling relationships out of mixed structured data when relational databases easy. It was one of the first attempts to make a natural language programming language to where you could kind of speak and easily understand what you were saying in human language as opposed to writing codes and dots and array indexes. So structured query language is what SQL stands for, and that's how it's pronounced, SQL or SQL. Please don't mess up and say squeal. That's just not good form. SOQL is the Salesforce version. It's Salesforce Object Query Language, and that is the implementation of the SQL language standard. But it's kind of a subset of SQL functionality and expands in some places. But if you know SQL, you'll have to kind of put your knowledge into a little bit of a box and understand SOQL more specifically. But if you already practiced with SQL, you'll find that it's not too hard to get into it, but you don't get to do a whole lot of advanced programming. Adam, do you have any comments there?
Yeah, I echo what you said. So I had done some SQL development in a college internship, and then when I started working with Salesforce and started using SOQL, like you said, it is very similar. I'd agree it's probably a subset, but definitely easy to pick up and a lot easier to understand if you've done SQL before. But yeah, as you said, kind of a subset. It's a little limited, I think, and specifically in relations to all the unions and joins you can do. But it has kind of been customized and tweaked a little bit to meet Salesforce specific needs and help you query Salesforce data in your applications.
Yep, absolutely. Yeah, there's some weakness, and some limitations, but it's really expected to be used for gathering data quickly and not really writing kind of full-on programs or doing a whole lot of logic inside of SQL or inside of SOQL. And I pronounce it SOQL. You pronounce it SOQL. I would defer to your pronunciation.
I've heard both. I know people that say SOQL. To me, like SQL, I pronounce the Q. So SOQL, I pronounce the Q there as well.
Gotcha.
But I don't know what the right answer is though.
Yeah, I think I just I think I read and have only listened to my own pronunciation mostly. So I'm realizing that I didn't think about that before deciding that that's how you pronounced it. So with SQL and SOQL, there's four main functions that you're trying to do. So this is a language designed to pull data out of structured data. And we'll talk about relational data and structured data a little bit. And some of that we covered mostly in our first session. But the functions are to filter data. So if you've got a large store of data, you only want the certain records, people that live in a certain state, people that are assigned to a certain account. If you want to get the data back in a certain order, like, accounts opened and the date they were created. Now, for SQL, you've got another part of the language that allows you to do updates and inserts. SOQL doesn't really give you that. So that's one of the things you need to learn to program. And I think we need to show the anonymous Apex version as well if you're looking to do general database stuff. And there's some other tools we'll mention at the end, like Workbench for altering data, gathering it and querying it, and then joining data. So joining we'll talk about later, and it has to do with merging together different sets. So if you had different spreadsheets with related data, how to pair the records in one spreadsheet or one tab to another. But one of the things that the reason that you have this, and a lot of the reasons behind it, it's important to know that there's a space and effort, CPU IO, that you're trying to manage. Databases try to structure data efficiently and allow for joins and relationships to be pulled and built and visualized quickly. Getting your data to your screen from storage, this is the vehicle that does that. So everything is a big jumble and a big mess until you use SOQL to pull the data into Salesforce, into your program or into your automation, or Salesforce uses its own behind the scenes version of it to put it natively on screen. So understand that this is going on behind the scenes, and a lot of the forms patterns that we're going to talk about have to do with building around that efficiency. And we'll try and cover why it's efficient, but mostly it's just important to understand that that's the back end. So if you've got questions about why something's there, there's usually an efficiency reason behind it. And then there's the other side, if anybody's delved into NoSQL, where flattening and making data non-relational is faster because joins tend to be costly from a CPU perspective. So there's a give and a take. Computers have changed a lot since SQL and SOQL were created, and so there's another side of this coin. But this is still your primary tool for moving data out of data storage in your Salesforce org into your program and automation. I miss anything there, Adam? Sorry for my ramble.
Yeah, no, I was going to say, yeah, you probably know SQL a lot better than I do. For me, joins have always kind of been a little bit of a beast to think about. And I know there are a bunch of different joins and I mix up which one is which. I think the most common usage for me is going back to the Excel example, using the VLOOKUP function, where you're like trying to match two different sets of data based on some common field. So that's kind of the most common example of a join, I think, that I've used. But yeah, no, there's a lot of different ways to basically combine data sets and get the values you're looking for.
Yeah, that's a good point. Well, hopefully we'll cover the different types of joins, or maybe we'll ad hoc ad lib on that here in the next couple of slides. So if you're an admin, I think Adam's going to talk us through that. And reporting is not my strong suit, but that is, I think, most admin or Salesforce first approaches to where and how you usually pull and look at data through the UI.
Yeah, so I'm a big believer that admins oftentimes tell me, hey, I don't understand code. I don't know how to think about code. I don't know how code works. At the end of the day, a lot of the tools you're using as an admin is doing code behind the scenes. And a perfect example is with reports, right? If you think about how a report works, when you build a report, you start out by telling it, hey, what objects or what tables do I want to pull records from? You go and tell it, how do I want to group the records together? What fields do I want on the different objects I'm querying? And then you also have the option to put in filters to limit your data set. So here we have an example at a contacts and accounts report. I want to pull contacts with their parent accounts. I want some fields from the contact object. I want some fields from the account object. And maybe I'm going to put a filter on it. Maybe I want them to be from a specific state. Maybe I want them to be created within the last year, the last quarter. I also have the option to group contacts together by account, for example. And at the end of the day, all this really is a database query, right? I'm just querying some records from some table or tables that are related under some condition. And with custom reports, same sort of thing, right? I have to choose what objects I want to kind of build my custom report type on. Those objects have to be related in Salesforce. There has to be some sort of lookup or master detail relationship between them. And that's the same sort of thing. So when we're going to talk through some examples of SQL and SOQL, at the end of the day, you can kind of think about it very similar to how you run reports in Salesforce, right? It's a record query on objects that are related based on some filter criteria.
Great. Yeah, and I think that's really. Would you agree this is kind of a baseline understanding for what we're going to go through with SOQL here is if you haven't taken it's a couple of trailheads on reporting and how to pull data into reports, then I would definitely kind of pause here because you probably won't get that. We're going to kind of assume that you've got at least that report level knowledge of Salesforce. All right, and I've got a Excel spreadsheet, but these are pulled up really directly from data that's inside of Salesforce. So we went into the dev console, and maybe I can pop into code really fast. Oh, I did not log into my trailhead. Let me. All right, can you voice over while I log in, Adam?
Sure. And so, yeah, we're looking in here. Basically, this is you create a new dev org. You're going to get a bunch of kind of dummy data, and this is kind of the dummy data in Excel form, right? In the top table, we have a list of accounts, and in the bottom table, we have a list of contacts under those accounts. And you'll notice, I think we talked about this last time, that lookup relationships, while they show up kind of with the name in the Salesforce UI, under the covers and behind the scenes, they're an ID. So if you look at column B there in the bottom table, that account field on the contact object is really an account ID. And so we can see, again, starts with 001 to tell us it's an account, and it corresponds to a record in the account table. And so hopefully you can already kind of start thinking about how we showed in the last slide with the report, where I'm showing contacts with their parent accounts. We're going to be able to do kind of a join on, again, contacts with their parent accounts, just maybe in a different format. And again, in SQL, I feel like you're able to join, and maybe you can correct me if I'm wrong, Paul, you're able to join tables that don't necessarily have a direct relationship.
Yeah, that is actually,
Salesforce, you are not able to.
Yeah, and that's actually the beautiful thing about SOQL compared to SQL. If you, with SQL, it's assumed that there may be relationships between tables, and you have to tell tables how to relate themselves. With SOQL, in Salesforce, in the setup of the tables, you build the relationships, any references, and the joins are almost automatically taken care of for you. It assumes that if you're referencing another table, that you're using the join that's built already between those two tables, and those IDs, the primary and secondary keys, are automatically matched up when you say, I want this data from this other table. So it takes that all of that effort of writing the join and managing the join out. It's there automatically when you set up the table, or whenever you set up a linkage, a junction between two tables, whether it's a reference, a junction table, or a parent-child master detail record. All right, let me hop into Dev Console just to show how I mostly get to and look at data inside of Salesforce. All right, if you've got my screen and you're going to lose it for a second. So I'm going to go here. I'm logged into my playground. I am going to go to Developer Console in the setup window, and it's going to pop up in another window. And I'm going to take the URL and come right back with it, which is a fun little bit of a hack. So I'm going to close the Dev Console window, but I'm going to come up and paste the URL from the Dev Console, and that'll open it up here.
Another hack actually you can do to do that, I think if you hold, what is it? Control? Command. It's Command on the Mac. It might be Control on the PC. When you click on Dev Console from that bar, it should open up in a separate tab.
It sure does. That's beautiful. Yeah. Thank you. All right, so if I were to go into, and let's say I've got account already open here, but let's pretend like I didn't. I would go in, open to my object. I can start typing account. There's account, and it's going to pull up all of the names of the fields within account. And one of the nice things that it does is that the most newly created fields go at the bottom. So if you're dealing with new records, they're always sorted down to the bottom by the default look, and it tells you what type of data each one is. And it's got a fun, an easy kind of a WYSIWYG. I want the name, I want the ID, I want the type, and I want the phone, and how about the shipping country and website, and I'm going to hit the query button, and it builds that query down here. It's building the SOQL for me right away. And then I hit execute, and it's going to give me the results of the query. So the name, ID, and actually I did it in the order I typed them. That's neat. Or the order that I clicked them, control clicked them in the selection. Phone number. So these are the columns and rows that I requested from the account object. I didn't add any filters. I didn't say where shipping country equals that, but that's an example of the filter, and we'll start talking about that in a second. But that's my quick way to do that. Sorry.
Yeah, I was going to say real quick before you jump away, just again, going back to the report example, if I run a report and say I want to report on the account object with these same fields, right? The ID, the name, the type, the phone, the shipping country, and the website, it's going to give me the same 13 records that we see in the SOQL query.
Oh. All right. Stop sharing. All right, so those are tables. We just pulled all the data, or at least some of the data from the account table in our trailhead, and then putting that into Excel. You can visualize it as tabs inside of Excel. Now, when we want to pair two tables together, like pairing records where we tie and we do a join in SQL, and I'm probably not going to go through this, but I just the visual query builder that's inside of Excel. Maybe I'll go ahead and look at it. Let me share that really fast. So, okay. Cannot stop clicking that button.
And while you're opening that, people also may be familiar if you used Data Loader before. If you're selecting fields from within Data Loader, you also notice a similar kind of SQL builder inside Data Loader to construct the query before you do like a data export, for example. It'll kind of build the query there, and you have the option to manually edit it. But if not, you can just select the fields from whatever object you specified, and it'll build that query for you there as well.
So here I pasted the data from a different pull from the account table and from the contact table inside of one of my playgrounds. Now I have gone through in Excel, and I've labeled this range as a table, and I've also told it that the headers are the names of the columns inside of it. And so I'm going to use, or at least I'm going to try to use. I'm going to go to data, get data, other sources, and Microsoft Query. And this is just a tool that's built into Excel. Let's see if I can get this fairly quickly without too much flailing. Oh goodness, there it is. All right, and now I can add the accounts table to a query, and that's not the right one. Account table, how about that? There we go, and then hopefully this will be the contact table. There we go, I've labeled the IDs. Now I can go next. That is fine. So now it is telling me in the account table and the account ID, and it's pulled back all the records and columns. And the contact table also has a field called account ID. And I should be able to drag this. And now it has joined the contacts. So I have every contact that is related to an account. And if I have doubled up account IDs right here, you can see the AA2, 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 FVY. Let's see, and that should be account name, Edge Communications. Anyway, these are the same two accounts.
Two are the same, yeah.
Third one looks like the ID is the same, but it's saying that
I think it's FVX versus FVY.
You are correct. I'm just cross-eyed at this range. My light makes it hard for me to see. So I've got, it puts two entries in here for the same account because Sean and Rose are both contacts that are related to the same account. So that was an easy drag and drop join, fairly easy. A little bit too much clicking there. But that's how you write WYSIWYG, SOQL, and then you've got a SQL viewer here that will show you. And this is basically, I'm selecting all the columns that I want. And then it's saying from account table and contact table. And this is the important part. This is the SQL version of a join where contact table.account ID is equal to the account table.account ID. It's saying wherever these two are the same, then add the data from the other table to that same row or make a duplicate of the row if there's multiple for it. So you get a list of contacts with their account information. All right, let me hop back.
Yeah, I think we'll see in a second here the difference between a SQL query and a SOQL query, because I think the SOQL one's a little simpler, which I prefer. But on the other hand, the SQL one potentially is more powerful, and you can do more things with it. So trade-offs, as with anything, I think we've mentioned that before as well.
I need to hop back to the same. Well, let me just describe it here. So these are two different, I'll not do the screen swapping fun, but normalized and denormalized. And you really don't need to know this. Normalizing is flattening. So this is kind of the structure that you will see. If you had a list and it showed Adam and I's name and titles in it, and we have the same title, but inside of this table, these characters that make up our title are repeated 2 times or multiple times if there were more people that had the same title, which to the database is a lot of space. Now, what is a more efficient way to do this is to break this up into 2 tables where Paul and Adam's information and a code for that we have the same career title or same job title is represented with a code, and there's a 1 entry where the repetition of these characters is taken care of by just putting the code number, and in here it's just a 1. So this table with 1 copy of that duplicated data is a more efficient way to store that data. So anywhere you've got something that might not be unique. My first name and last name, that's probably too unique to have a table of people's possible first names and people's possible last name. But where there's repetition, like job titles, you would pull out that data and make a separate table and try and efficiently store the space, efficiently maintain the space. And if I don't need that extra data, I don't join on that table. If I do need it, I join it. And joins can be costly. And if they're done over and over, then you might have a good reason to have that data directly in the table and not broken out into a separate table. But for the most part, you want to structure your data to where you can manage different lookup tables and different relationship tables out separately and be very efficient with storing of just codes. This would be called the primary key of the career table, and it's stored as a foreign key inside the person table. And then 2, 3, and well, if there was an ID field in here, that would be the primary key. And it's referring to the foreign key of the other table. I think I called it secondary before and it stuck with me. I know that's not what that was called, primary key and foreign key. So yeah, that's a sample norm. Yeah, sorry, go ahead.
I was going to say, going back to the Salesforce example, similar if we go back to like accounts and contacts, right? If you look at the contact object, the primary key is going to be the ID and the foreign key is going to be the account ID on contact, because on the account object, the primary key is the ID and it matches up with the foreign key account ID on contact to tie those tables together and let Paul do what he did, where he showed all the contacts matched up based on their accounts.
Yep, and inside of SOQL or inside of the dev console where we're looking at the data, you can see the actual foreign key stored there inside of any reference table that's pointing to a related table. But SOQL doesn't make you talk about them. It knows that's there, and it knows if you're asking for it, that's all you need. So here's another sample of SQL, and that was a SQL that we looked at inside of the Excel table. I've just cleaned up the names of the columns that you're looking at, and I've created an alias for each of the tables, so I can use the alias as a shorter version. That's done sometimes in SOQL, but not always. So you're saying what the actual backend name is and then giving it an alias name so you can refer to it from then on. And then I join based on these two contact table and account table IDs. And we've named them the same, but they don't have to be named the same. Your reference ID may not be the exact same name, but here with SOQL, you don't have to do that. If you say if I'm looking for something inside of contact, it's the relationship to the account, you just list the table. Because that relationship is already there, you're done. And you're really only talking about contact, and it joins in the other table based on that relationship automatically.
Yeah, and I think that goes back to, right, Salesforce doesn't really allow you to query things that aren't related. So in SQL, I have to give them an alias, and I have to explicitly tell it, hey, I want the account ID on contact to match up with the account ID on account, because account and contact may not be related in my SQL database. Whereas in Salesforce, I can't query them together unless they're related. So SOQL kind of takes care of that additional functionality for me. And so the SOQL query looks a lot cleaner, at least in my opinion, than the SQL one, because I don't have all those aliases. But again, that's because it's more limited in the power of what it can do. So pros and cons, but to me, I think the SOQL one's a little bit easier to understand.
Yeah, no, absolutely. All right, so the SOQL statement structure, the language, the grammar of the language that you're using is pretty much the same always. You're selecting, if you're for reading data, whatever, it is a data query language only for SOQL. SQL, you can update and insert and delete records. You can't really do that with the SOQL language. So SOQL is explicitly going to be select statements. Now, when you want to delete, you'll be deleting records based off of a select statement, but that's a little bit later. We may get to that in some of the last slides. But so you will select all of the tables, all of the columns from the tables that you want to query. In SQL, you can use star. I think there are a handful of hacked places where you can substitute in star, but that's one thing that SQL developers miss a lot when moving to SOQL. Star is just to say you want all fields, but you can do that in some ways inside of SQL, inside of SOQL, but not natively in the language. From a table, adding a filter or a join, adding filters with the where. You can't specify the joins, but you can specify your narrowing. And then if there's a subset, there's some conditions that you can add where you're referring to other things. And I'm drawing a blank on conditions. Have you got a good example in conditions?
So I think it was just like, it just means I put a condition after the where clause. So like where state equals California, where annual revenue greater than $1 million. And so I think the key takeaway for me here is every query you see in SOQL is always going to have the word select. It's going to be some fields. It's going to have the word from, and it's going to be some object name. And optionally, I can have the word where and a condition to follow it. And again, if we go back to the report example, right, we see the fields in the columns to show section. We see the from in the whatever report type it is, the objects we choose at the beginning. And then in the filters tab, we can basically specify our where clause. What filters and what conditions do we want to put on that record query to limit the amount of records we get back?
Yeah, condition, sorry, yeah, explicitly, we got right here. Limit is something else that you can add to limit the number of returns. That's another keyword that's in there. There's some aggregate conditions that we can talk about later, but it's always select and from. Where is optional, and as you're building wheres, the order is if you have a filter, you start with the word where. If you have a second or more filters, you add and then you add each of your condition after an and. So always have to have one where, and any additional filters start with the keyword and. So select from. Yep, sorry.
You can say you could have or also, and you can kind of like with your custom filter logic in like workflows and stuff like that, you can kind of specify, okay, I want it to be these conditions or that condition, or
yeah.
any of these three
Yeah,
conditions.
sorry, and an or, of course, yes. Sorry, yeah. And
yeah,
then
to your point, you
there's
can have
also
multiple conditions.
there's another one that I don't have listed here that it gets a little bit more complex, and I don't think we're going to go into it. But in is another keyword that you could put in where you would nest a subquery inside of it. So any of the elements from a subquery would be added in as an additional filter.
Yeah, I think that one might be on the next slide, actually.
Yep, you're right. Yeah, so limit, put a cap on how many records, such as, the limit 10 records if you only want to return the first 10 records. Order by, another condition, setting the ascending or descending order based on a field. An order by is based on rules about the fields. So dates could be ordered in the, from past to future or future to past as ascending or descending. Monday to Friday, if that's a text field that you have in the database, that would be alphabetical if you stored it in there. If you stored it as the date, you have to reference some kind of number that could be ordered. So there's a set of, you have to start doing field-based math and understand where the system can translate a number that's orderable. And that's one of the reasons we'll talk about how indexes help with that a little later. But number fields, easy to figure out how they're ordered. Text fields, if they have a representation like Monday is day 1 of the week, you have to figure out how to build a translation if just the word Monday is stored in there. Now you can figure out the actual date and order by any dates because those turn into a single number field and have a direct mathematical representation that you can order by. Offset's a fun one where you can do paging and you can say, well, I got the first 10 in the last query. I want the next 10 for this query. And yes, in and not in, it's filtering within a set or a subquery subset of data from another table. So as long as you're pulling back the right field that corresponds to another table, you can say, you can use a subquery to limit a parent query's return values.
Yeah, just kind of some high-level examples like for order by, and I think you mentioned you could order by multiple fields. So I could say like I want it to be first order by last name ascending and then create a date ascending. So it'll order them all first by last name. If 2 people have the same last name, then it'll specify, okay, who kind of was created first, and then it'll order them in that order. And so that also lets you kind of manipulate the way that your records end up getting returned.
Yeah, if you're doing accounts and opportunities, I want a list of my longest term counts first, but I want to look at their most recent opportunities. So I could go by account create date, ascending, and join to opportunity, and the opportunity name by the ID descending. Yep, largest first. All right, bind variables. So when you're actually working in code, one of the ways you won't have fixed and be writing out your queries. Adam, you want to take this slide?
Sure, yeah. So basically bind variables allow you to write more kind of dynamic queries. So for example, I don't always know what I want to query. I might be taking some user input, or whether that's a user typing something in, think of like a form, user clicking on maybe a record somewhere on my page. I might need to restrict what I'm actually querying, and I might need to base it on some value I'm getting from a user, some value that I calculate, et cetera, right? Think about like when you're looking at maybe, you're looking to rent a hotel somewhere, right? And you have the option, okay, I want to look at all the hotels with a maximum price of, $100 a night, or a maximum price of $75 a night, right? The query that's running behind the scenes is going to change depending on what you type into that maximum slot. And so in SOQL, we can write queries using what's called bind syntax. So it's just a colon we see there. And so here we have a variable called last name filter. we gave it the value of green. And now in our query, again, we see the word select. We have some fields. We're querying from the contact object, and we're specifying the where clause where the last name is equal to whatever our last name filter is. In this case, it's green. It could be something else. And so if we run this in a dev org, we're going to end up with one contact returned. It's the person with the last name of green. And that's because that's what we told it to query on. So instead of having to hard code, give me the person with the last name green, we can change last name filter potentially from a user input and get a different set of results for the same query.
Yeah, there's a perfectly atomic piece of code, and it's just like really the first piece of Apex we're really getting into. Line number 1 is creating a variable named last name filter, and it's instantiating it as type string. There is no new in this syntax, and he's setting the value of last name filter to the text string of green. A variable of type contact, which is actually going to be a multi-value. It's going to be able to select, because it's a list, it's going to be able to take multiple rows of data returned. So if there were a bunch of people with the name green, the new variable called contacts would be able to hold an array, a list of contact variables. So more than one, it's a multi-value variable type, an array variable type in other languages, or an object or struct from even more. And pulling that in, your bracket starts your writing of explicit SQL. This is a native SQL language, which has a variable substitution character. If you put right here at the beginning, no spaces, before the name of a variable that exists in your code, it'll substitute that value in to your SOQL statement, and then execute that SOQL and store the data into your list contact variable. Here it only stores one, so you'd have a list with only one element, or at least that's all we're showing here. So welcome to database programming. So great piece of code.
Yeah, and this is kind of another example of something we can do with SOQL. So think about a scenario where you're looking at a directory and you want to maybe find your name. And so you click on, right, you don't know, you're trying to find someone. You don't remember that the person's name is green, but you want to see everybody whose name starts with the letter G. So we can use what are called wildcards in SOQL, and it's represented by the %sign. And we can also use the like keyword. And so here, once again, in line 1, we see we're declaring another list variable of type contact, and we're setting it to a similar SOQL statement from the last slide. But instead of setting the last name equal to a value, we're saying we want the last name to be like the letter G and then the %sign, so our wildcard. And this means it has to start with the letter G, and then it can have anything after it. And so in this case, if we run this query in a dev org, we're going to get all the contacts whose last names start with the letter G. So once again, we have green, but we also have Gonzalez and Gray. And so we're able to use percents and wildcards kind of at the beginning of words, at the end of words, and it allows us to have more flexible queries. They tend to be a little bit more expensive, so do use them sparingly, but they also do have their place and can be very useful.
Yep. Now, the like keyword means tells SOQL to look inside of the string that you pass it and find any wildcard characters. So percent is a wildcard for multiple characters. I haven't tried to use it, but usually where percent's used, question mark can be used to take the place of a single character. So if you knew somebody's, it was Green or Glenn, you could put a GL or a G question. That's not a very good example. If it's go or if it's got or
gray and green here also.
Yeah, gray and green. Yeah, you could put, well, it had to be 2 E's. But yeah, anyway, the question mark could be a single wildcard. I can't think of a purpose with a single letter substitution, but there's there. If you accidentally typed equals instead of like, it would look for any last name that was G with the % symbol in it. So you have to put the like in there to tell it to parse the % symbol. It may even be protected. You might still have to escape it, escape the character, and that's something that's a little. Look up escape characters if you start running into or trying to get fancy with wildcards. That'll be an important concept later. I think we should almost have a whole session just on what escape characters do, because that's ends up being super important.
Mhm. All right, so some other cool things we can do, kind of going back to the examples we talked about toward the beginning, we can join tables together in what are called relationship queries. And we can query up, and we can also query down. And so again, if we go back to the example with reports, I could have contacts and I can query up to accounts. I could query the accounts and the parent accounts. And in SOQL, you can actually query up to 5 levels using dot notation. So I think they did this because there's an example where I can query, I think it's opportunity product line item, up to opportunity product, up to opportunity, up to account, up to parent account. I think there was like 5 levels in the schema, and that's why it's 5. But I can keep querying up using dot notation. So you might be familiar with dot notation if you built a formula, if you've built kind of some automation and are putting in values. You see it'll show up with dot notation, but it basically just means this relationship's parent fields. So here my example is I'm looking up contacts, and I want from the contact object the ID and the last name, but I also want the parent account's name field. I want the parent account's ID field. I want the parent account's parent ID field. And then I want the parent account's name. So here I'm going up a couple levels above contact. But at the end of the day, I'm querying from the core object contact, and I'm going up from there. The other direction, we can also query down. And so now we're going to start with the parents and query the children. And here we're only able to go 2 levels total deep. So here I'm going to start with the account object, and I'm going to query down to contacts. And this is going to use what's called a subquery in SOQL. And so now I'm going to start off querying what I want from the account object. So that's going to be the ID of the account and the name of the account. And now I'm basically going to treat my subquery like it's another field. And so again, I'm going to have a comma, I'm going to add a set of parentheses, and I'm going to put my contact query in there. And so in addition to the accounts, I want all the contacts under those accounts. And so I'm going to have a second query, select ID and last name from contacts, notice the plural there. And then I'm going to continue it after I finish my subquery, finish the parent query, because ultimately I'm querying from the account object and querying down as well. And the key to remember here is that when we're querying children, we always have to use the relationship name. And I can show where to find that as an example here. You might also see, in addition to __C, the __R is used in a subquery to indicate a relationship.
Great. And dot notation is a big topic, and we happened on this, and it didn't occur to me exactly how important understanding that was, and that took me a while when I was learning to program. Understanding that, so we're just looking at this right here. So this is referring to one element nested within 2 structures. So this is the name field inside of a parent record inside of an account. So if that relationship has been established, and you can say inside of account, I'm going to reference another account, so I can list one account being a parent to another account, and that account could be a parent to another account, and you could drill all the way up the tree as many times, up to 5 times, and that's an important limitation to understand. If you have a relationship that drives more than 5 levels, you're going to have trouble writing SOQL around it, and you might want to think of building some other relationship structures ahead of time, or rethinking. You may have too complex of a data structure and want to get some outside help and reformulate it. But that dot notation, this is a field inside of a record attached to, that's related to another record, and this is a field connected to an ID connected to another ID. So understanding that relationship is there, and getting your brain around, when you see this, you've got to see a 3-dimensional, 4-dimensional cube with, if it were just 2, it's an X and a Y. If it's 3, it's an X, Y, and a Z. If it's 4, it's every X, Y, and Z element has its own tail spinning off of it. And your brain has to start to get used to building those relationships and cubing that a little bit. So dot notation, important thing to get familiar with and understand what it means. Maybe easy for some people, but it took me a while. And I'm confused, Adam, and I struggle with this. Actually, I have to do it wrong, or I have to let query builders write it for me. So why is it contacts here and contact here? From contact and from contacts?
Sure.
Why would it be
So
different in each spot?
Yeah, so I can show why it's contacts plural. The important one to remember is from contact. That just means I'm querying from the contact object contact table. So that's going to be whatever API name the object is. So let me show the difference here.
Okay.
So I'm going to go share my screen real quick.
I'll bet since it's a standard object, the contacts is the name of the relationship in the standard object account, and it doesn't have the __r. Finally crystallized. I'm sorry you didn't get a chance to explain it yet. I'm sorry, already have.
Oh, you're good. You're good. So cool. So I'm looking at the contact object here, and I see the API name for the contact object is contact. So that's why the first one we queried was contact. If I look at the fields of relationships on contact, the lookup relationship to account is here, account name. And if I click on that, it's this child relationship name that specifies what the value has to be for the subquery. So here, because the child relationship name is contacts, that's why the subquery is contacts. And so if I look at a custom object example in my org here, I have two objects. One is called store, just store __ C, and one is called store revenue __ C. And store revenue has a lookup, or sorry, a master detail rather, to store.
So you created that relationship to the store table and called it store.
Correct. And when I created that relationship, I also specified the child API name, store revenues plural. So by default, it always makes it plural, but you can change it if you want. So for example, if I create another relationship to store on here, let me go choose store again. Hopefully this is the right store. But it'll ask me what I want the child relationship name to be. And so that's where I could specify what it is. So here I could say, maybe I have some filter on there. So I could call it new store revenues or something like that.
Okay, and that wouldn't be __ there?
So when you're creating the API name, no. In the subquery, yes. So let's just call this store2 for simplicity for now. And we'll show the differences in the queries. So I'm just going to create this, move on. Related list label is fine. New. And I'm going to go query both of those now. So once this saves, bring the dev console back up. Okay, so now I have these two relationships here. So my first one, I could say I want a list of stores. Stores equals select ID and select ID from store revenues __ R. So this is where the __ R needs to be used because it's a custom field.
Okay, so we just didn't see that whenever you called it store revenues. You put the store _ revenues and the __ R is added automatically.
Correct. Just like when I create an API name, the __ C is automatically added.
Gotcha.
To the end of the value. So like for this new field I created, for example, I called it store2, but the field name is actually store2 __ C.
Right.
So here, this will give me my first list of stores. And if I want my second list, I'm just going to actually copy this, paste it here. And now I'd have to say new store revenues __ R, because that's what I named the child relationship on this second lookup relationship here.
Gotcha.
So if I ran these two, yeah.
Okay. Sorry, when you're doing a subquery, you're doing a subquery against the relationship, not against the table.
Correct. And so that's what's going to govern what this value is here. And because it's custom, I have to include the __ R, whereas for contact and account, I didn't have to. So if I go query these now,
it's going to
name it
store
stores2, yeah. And now I didn't understand new store revenues. Let's see, why is it mad about that? Did not understand. What did I do wrong here? Select ID. What ID? Store revenues. From store. Looks right. And not give myself access to this, maybe. Entirely possible.
I didn't think you had to use the R unless you were dot notating it, but
I'm pretty sure you should, though. Okay, I'll have to take a look at that. Let me highlight this in the meantime. So this will run. I'll have to take a look at why that wasn't working, but generally that's where you pull that from. So
Gotcha.
here I just have two store values. And again, it's going to be querying the parent object. And if I want to reference the child records in here, I'd have to do something like, for store and stores, I could say.
Oh, Adam, you've got two froms, don't you? Oh, no, you've got, okay, close the parens. Sorry, I'm still.
Oh, yeah.
Yeah, never mind.
I copied it here, so it should be the same. I'll have to take a look at why that wasn't working later. Equals s dot size. So basically it treats this as its own list like I have here. And then I can do something like this, and then system.debug total is. And then this will basically tell me how many store revenues are in each of my stores. And so if I run this here, so right here is the list representing each store revenue, each list of store revenue records under each store S. And then I'm just getting the size of that list. So here, this will print out each store and the number of revenues underneath each store. I don't think I actually have that many records in here. But if I look at this in here, I'll see that in one case, the total is 3, and in the other case, the total is 0. So for each of my stores, there's a separate list of child store revenue records it's querying there.
Yep. This is the, and you're doing the anonymous Apex from inside of the dev console, which is where you can write code and SOQL to kind of manipulate data. And this is where if you were trying to take the results and you wanted to delete some of the records, you would add another line of code, like at the very end, you'd line 11, and I want to delete those 3 stores. You'd write a delete statement and reference the stores to object. And as long as it had IDs in it, you'd be able to delete those records. So this is your SQL Plus from my old school Oracle days, your SQL editor and querying tool if you want to mix your queries with code and do any deleting. Great.
Yep. Right.
All right. And dynamic SOQL, I think you showed an act where you will start doing this. Let's see, I did not pull up and put in a screenshot of an aggregate. Do you have one handy?
So, I have an example of a dynamic SOQL, and I can try to construct an aggregate query on the fly. Count I can definitely construct.
Okay.
Let me share again here. Cool. So when we're talking about dynamic SOQL, basically, right, so far we've been talking about, right, I have a query, I know what object I want to query, I know what fields I want to query, and I can use things like bind variables to manipulate the condition. What if I don't know what fields I want to query or what objects I want to query? I have the ability to construct my query on the fly. And I can do that using dynamic SOQL. So for example, I might have a situation where I don't want to have to write 2 different methods to query the account object and the contact object. So I might have a method that looks like this called run query, and it takes in as a parameter a string value corresponding to an object name. So it'll either be account, or it'll be contact, maybe it'll be something else later down the road. And so here I could specify another string value, just a list of account fields. And here on contact, I could specify a list of contact fields. And depending on what object name we pass in, we're going to construct a query accordingly. And so I can actually print it out here, system.debug query is, and this is actually helpful. After you construct the query, it tells you something is wrong. You can see what the query was supposed to be. But we're going to start off again with our select statement. Every object is going to have an ID, so that's fine. And then we're going to check to see if in line 7, our object name is account. We're going to add the account fields from line 4 to our query. In line 9, we say, okay, if the object name is not account, if the object name is contact, we're going to add these values from line 5, the contact fields, to our query. And then no matter what at the end, we're going to add again the word from, and we're going to add in the object name that we passed into the method. And then we're going to print out our query. And instead of running the SOQL statement in the square brackets like we did before, we're going to call this method database.query. And we're going to pass in our query string we defined in line 6 and we built up. And then line 16, we can print out how many records we queried from each object. So if I go open execute anonymous again, and I do something like dynamic SOQL dot run query, pass in the account object, and then I do the same thing and pass in the contact object, right? I can run both of these, and it's going to print out. Let's see. Did I not save this? Oh, I didn't save this. That's why it's not printing it out. Let me save it and then run it again. And then it'll print out my query and how many records from each table I queried. So it's for the first one, we ran dynamic SOQL with account. And we see here, the query was select ID, billing street, billing city, and billing state from account. And we queried 15 records. And then the second time we ran it, we queried select ID, mailing street, mailing city, mailing state from contact, and we queried 20 records. And so this is useful. Sometimes you have two objects with a similar structure where maybe the field names are the same, but the objects are different. Or like this, where the field names and object names are completely different. Or in some cases, maybe there are some scenarios I want to query one field, in another scenario, I want to query another field. If I'm building a custom where clause, again, maybe I want, right, think about that hotel example we talked about before. Maybe you want to filter on, the price per night. Maybe you want to filter on distance from a certain location. Maybe you want to filter on number of beds, right? There are different things you can query on, and we want to potentially be able to have a dynamic query that'll change based on what you're putting in there. So that's why dynamic SOQL can help us out in that respect.
And you've got some great code here. I want to talk through it line by line here. And you've got a class and a method listed in here. And we'll skip that. We have another session we want to talk about that. But really quickly, just to add in what we're talking about here, we built our SQL sentence, our SOQL sentence. And our SOQL sentence has a grammar to it. Select, from, where, and other options. And when we're building code, sometimes we might not have the luxury of knowing exactly which fields we want to select, and we want to be able to build up that sentence and start the noun part, the select part of the sentence, which would be the selects. And so Adam is he's creating a variable called query, and he's setting it equal to this text, and then after the comma, he's got an important space after the comma. And when you're concatenating, and that's when you're starting to add strings together to build a single SQL sentence. So you're starting with a noun, verb, and a filter. You want to build that sentence properly. So you want to respect all the rules of grammar as you're adding these pieces of it together. So he's built in an extra space here, and then The plus equals, I love the plus equals. Oh, please leave that. I hate it when people don't write plus equals.
It's a little easier to understand maybe, but it's essentially, I can leave it in for this one. It's essentially doing the same thing.
Yep. So yeah, the symbol here, when he's storing the value of the current value plus the new fields that he's adding, which are this string up here to this verb here. So in order, it would be query and then the account fields and then the contact fields with his dynamic SOQL. And then he's adding those together. And this symbol right here, it basically takes the place. It's the plus equal symbol, which is basically whatever's in here, keep it and add to the end of it the new values that are stored in that new variable. So you'll continue to see this, and it's nice. It's a very easy text saver so that you don't type the value of the variable each time, and you're just saying add more to the end, add more to the end, add more to the end. And then when at the very end, this last statement here, he's got all of the full sentence stored in the query variable from these concatenation operations. So it's the difference. Equals is the assignment, and plus equals is the concatenate. Add on to keep the original data and add stuff to the end. So
yes. So line 8 and 10 are basically doing the same thing. It's saying take the old value, and the new value should be the old value plus whatever it is that's after this plus equals here.
And since it's a string, plus is not doing the mathematical plus, it is doing the join them end to end together and not figure out what the new number is. So it understands, Apex understands the difference between string addition and numerical addition. So query, if the number 2 was in query and the number 3 was in account fields, even though they're strings, they would come out 23. If they were number fields, it would come out 5 if you added it together. Now, that wouldn't work very well in the query variable since that was specified as a string, but just an example of casting and types that we'll talk about in the future, but wanted to go over each of those for your new developers. It's nice to get a piece by piece understanding here. This outer structure, this class structure, is something we'll go into in one of our later sessions on how this object-oriented programming works, but that's fun for a future day. All right, and the other topic, let's see, aggregate queries and group by, if you want to keep going. I got a sample aggregate query pulled up while you were sharing.
Okay, yeah, if you have a sample, I definitely struggle with the aggregate queries, aside from count. But maybe I'll let you, I can share the count example real quick.
Yeah.
But yeah, basically count is just a very easy way to figure out how many records you have. So I could say something like, so this will return an integer, contact count equals select count from contact. And again, we have the word select, we have the word from, but instead of specifying fields, we're going to use this special function count, and it's going to tell us basically how many records, how many contact records we have. So
I thought you would get an error there.
No, just wait. I might. Let's see. It looks like it returned 20. So we have 20 contacts. So here it is. Yeah, 20 contacts in my work here.
Gotcha. Yeah, count seems to work. Other aggregate functions like sum, average, min, max will rely on the group by function. So one of the modifiers, one of the conditionals that you can put into a SOQL statement, I don't think we'll go into too much detail here. That would be a good one for learning on the side. But the group by function says in SQL, you have to specify an order by. So if I wanted to get all of the accounts and I ordered, or all the contacts, if I wanted to select all the contacts, but I wanted to order them by account so that contacts with the same account ID would be grouped together. Well, if you said group by, it would enforce that, and it would have one record. It would group the account, same thing as ordering by, but it creates the concept of a group of rows upon which an aggregate function can operate. So if you said count and then you added a group by statement to the bottom of that. And I think we can go ahead and do that in your Apex if you don't mind. If you did contacts, you should be able to just add group by account ID. And now if your 20 contacts that were there, you should get back.
This, what is this going to return? Is this going to be a
yeah,
list?
it is going to be a list. Sorry, if you pasted that SOQL straight into the query editor, you should get the results.
I see.
Sorry, yeah, I only think in SOQL queries, and you can tell that I learned Salesforce by hacking it, the object at SOQL from the back end and not properly.
Yeah. Account ID. It looks like. Okay.
There you go.
And this actually is very similar to grouping and reports. Also, there's the functionality where I can create a summary report instead of a tabular report. Mix that up as a summary report, but I can summarize by a certain group, and it'll group all those contacts together in my report. And so
great.
here we see, let me
put a
query
comma
the account
and
ID also.
Yes. You may have trouble with any other fields.
Okay.
You might be able to pull, actually, since it's the summarized field, summarized object, you should be able to pull all of that. You should be able to put common name there too. But there's some.
Nope.
Yeah, it must be aggregated. Oh, you'd be able to put the contact. Oh no, we're summarizing. But yeah, sorry, there's some fun here, and it's not super easy to remember when it's there. It's very powerful. Usually you can only put one. It's like, but it would have to be a field from the contact, or it would have to be the field you're counting on. So if you could put ID in there. Yeah, so your
ID, and I don't think, because basically this is giving us a grouping. So it's giving us for each account ID, how many contacts have that account ID, basically.
Yeah, I always have to land back into this. It's a little counterintuitive, and you can tell even I structure with it, and it's one of my favorite things to do, is to go in and find how many opportunities per opportunity there are, or opportunity line items, count those, count opportunity line items that match a certain criteria, that's some other criteria that you're bringing in before you take that data and put it someplace else. So in writing Apex, this can be extremely valuable.
Yeah, definitely. It takes your brain a little while to figure out how it has to work, and sometimes the SOQL error messages, like we just saw, help kind of guide us. Yeah, like you said, very powerful in what we can do with it for sure.
Yeah, and I'm about my 6th data query language, so all of the different dialects cross over in my head pretty regularly. So it takes me a bit to sit down and get these going right. But this tool right here, compared to a lot of the other ways that you can get data and query data, some of the aggregates, group by, and having some of the other powerful SOQL combinations will run only here, and you will have there are elements of SOQL that I've run into that you can't use in REST calls, you can't use when passing from Apex, you can't use them here. So I pretty quickly, almost exclusively, will do data querying and data review inside of the dev console, because I find it to be the most powerful and the least restricted of the console tools. Now, Workbench is another one that another subject if you're looking to query data on the regular, is a fairly common tool for people. VS Code, Adam, I know VS Code has some query elements in it. Do you feel like it's replaced Workbench?
Yeah, so there is a SOQL code builder in VS Code now. I don't know that it's quite replaced Workbench. I know they're definitely adding to it, and again, another option if you prefer that interface, but I think it also is a little limited in what it can do so far. But good to know that it is available as well.
Okay.
Yeah, I also do like the dev console just for the kind of visual UI it gives me for writing a query. And the other thing the dev console gives me in here under preferences, I can enable this query plan, and it'll basically tell me how efficient my queries are. So I can click this little query plan button that shows up now, and I can compare different queries to tell me how efficient it is, essentially. Here it looks like this is a bit of an expensive query. But in general, if I use certain fields and certain filtering conditions, potentially get some performance improvements by writing more efficient queries.
Yeah, but some of those fields that you'd include are indexable fields. And when you're dealing with really large record sets, concepts like indexes, which allow Salesforce to break the records into smaller groups, are really important. So if you get into an organization where you're dealing with a table, a million accounts or a million contacts, you may have to start looking into concepts like indexes, skinny tables, ways to get the data broken down, because the maximum SOQL statement that can be returned. So if you can't get a filter, Adam, if you did a count from, count may work since it's on ID, which is an index table. If you had 1 million records in contact, your query might not run, and you might run into a failure because you didn't have because 50,000 records in a SOQL statement is too many. Yeah, number of query rows returned 1 out of 50,000. So if you started to filter, if the filter couldn't get down to below 50,000 and it wasn't based on an indexed, and your index wasn't run, if it was too big to run without an index, you still wouldn't be able to get your filter down. So there's a lot of considerations, a lot of extra things you'll have to learn and research if you are jumping into dev inside of an organization with a lot of records, and other of the elements in the governor limits will pop out.
Yeah, one thing we run into, not even a governor limit, but I think like if it's not selective enough. So if you have like 10 million records, I think I forget what the rule is. You have to query like less than 20% max or something like that. Like there's a number of records it'll even be able to look through, and even if it doesn't return all those records, your query has to be selective enough where it doesn't have to scan all 10 million records, or it's not going to run also.
Yep. Yeah, you may have to, if you're working with data, just to pull the data out and maybe put it into an Excel spreadsheet for a side report, you'd have to figure out what fields were indexed. And you can see inside of your, can you switch back to your contact example? The tab you've got up there at the top for the object setup, your Chrome tab.
This one?
Yeah, if you go to fields and relationships, you can see over on the far right, the column, which fields are indexed by default. So any lookup is usually indexed, number of fields are looked up, and Adam sorted and grouped them together. The account ID, the pick list is indexed, that email, I don't know why email would be indexed by default, but
I think it's just Salesforce special contact field. They just index it by default because they know it's so widely queried.
Okay. So anything with that data type probably is going to end up indexed. Any of your other stuff, if you were trying to query a large data set based on mobile phone, you'd have trouble because it wasn't indexed, and you might have to reach out and ask for that field to be indexed, and state your case and why you needed to do that, and they'll do that on an exception list. But again, that's getting into bigger topics, so we don't necessarily need to go in too deep there. Anything else, Adam, we've kind of skipped over? I believe this is our last slide.
Yeah, I think that's was everything I wanted to cover, I think, for today.
Great. Okay, so our next session, let me full screen, clouds and code locations. So we've talked about a couple of different flavors of where the objects and the data are, but we haven't talked a whole lot about the syntax and where you write code. There's at least 4 or 5 I can come up with the top of my head, and there's got to be more places for you to write code within the Salesforce, different dialects of different languages. And so we'll go into that in our next session. So looking forward to that. That's a pretty broad overview. I think I originally had that labeled as session 0, but we'll put that back to the front of the line and have that for our next session. Any parting words, Adam?
No, great talking to you as always, Paul.
Adam, thank you very much. I actually learned something again from you, and that's pretty common. So thanks everybody for joining us, and we'll look forward to the next session, hopefully in a couple of weeks.